Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. The Quantum Leap: How Peter Shor's Breakthrough Will Redefine Our Future. Imagine a mathematician not just solving problems, but cracking the very code of the world. Sounds dramatic, right? Well, it's true. Meet Peter Shor. This genius mathematician nearly made all encryption systems unsafe. You know those bank passwords and social account verifications you rely on? They might as well be paper walls when faced with his algorithm. Picture this: you're buying a shiny new smartphone with your credit card, confident that your account is secure. But, in the blink of an eye, those so-called secure systems might crumble under the weight of Shor's algorithm. This groundbreaking algorithm could break the toughest encryption in mere seconds. And what it tackles is something most people wouldn't think twice about: the problem of factoring large numbers. Sounds boring, right? But here's the kicker: it's the bedrock of almost all encryption systems today. If it's cracked, the whole global encryption framework faces a major crisis. You're probably wondering, how could that even be possible? Encryption is so complex. Well, it used to be until Shor's algorithm came along, showing no mercy to even the most robust systems. But there's more to Shor's contribution than just cracking codes. His work touches on the future of quantum computing. Have you ever imagined a world where today's supercomputers look like toys? Shor's algorithm might just be the spark that ignites this new era. If you think quantum computing is something out of science fiction, think again. The potential of quantum computing challenges every tech system we have today. From global finance to state secrets, even your online shopping experience could be transformed. So let's dive into the world of the man who made encryption vulnerable, Peter Shor. Let's take a closer look at what he did, why security experts are on edge, and just how powerful his algorithm really is. Buckle up, we're about to uncover the secrets behind one of the most disruptive breakthroughs in modern science. Peter Shor was born in 1966 in Munich, Germany. And trust me, his family wasn't ordinary. His father was a chemist, and his mother was a mathematician. Genius genes? Definitely. Imagine growing up in a household surrounded by formulas, theorems, and chemical experiments. Sounds like a recipe for a future scholar, right? But here's the twist: Shor wasn't just your stereotypical bookish nerd. He had a sharp sense of humor, especially when it came to tackling those mind-boggling quantum physics problems. Picture a family gathering, talking about the latest scientific breakthroughs. His dad would say, "Can this chemical reaction be made more efficient?" His mom would ask, "How can we simplify this math formula?" And Peter? He'd probably be thinking, what if quantum computing could solve all these problems in a snap? Sure, his parents probably knew they were raising a prodigy. But I'm willing to bet Peter still tried to dodge his homework from time to time, just like any of us did as kids. Growing up immersed in academia, Peter developed a keen interest in math and physics. But he didn't just stop at the traditional fields. He was drawn to the mysteries and challenges of quantum computing. Imagine being a young person seeing the limits of classical physics and thinking, "I'm going to invent something that changes all of this quantum computing, why not?" So, Peter didn't just want to study math or physics, he wanted to fuse the two, creating something new. He started at the University of Munich, studying both math and physics, the first step in his academic journey. Before long, he was showing extraordinary promise, particularly in the realm of quantum physics. This led him to Oxford University, where he expanded his academic horizons and engaged with some of the brightest minds in the field. His goal was clear: create something new, push beyond the boundaries of traditional academia, and break into uncharted territory. By the time he reached his PhD research, Peter made a pivotal shift, moving from theoretical physics to quantum computing. This was in the early 1990s, when quantum computing was still a relatively unknown field. But he saw an opportunity and couldn't ignore it. Peter wasn't someone to jump into things rashly. He slowly and steadily delved deeper into the potential of quantum computing. It was during this period that he developed a profound understanding of the subject. Back then, the academic world wasn't too keen on quantum computing. It seemed far-fetched and too theoretical. After all, who would have thought of using quantum mechanics to do computations? But Peter wasn't swayed by the skepticism. He looked to the future, knowing that quantum computing wasn't just some academic dream, it was the key to unlocking a whole new world of possibilities. From Munich to Oxford, Peter's journey wasn't just about expanding his knowledge. It was about challenging the very foundation of established thought. He wasn't satisfied with the status quo, he wanted to approach the problems of physics and computer science with fresh perspectives. And that drive eventually made him one of the foremost pioneers in quantum computing. Now, let's talk about that moment. Peter Shor, the ordinary physicist with a PhD, did something that seemed impossible. He declared, "I can break your encryption." And that encryption? It's the foundation of the entire global financial system. Suddenly, the world stopped. Bankers began to reconsider their security measures. Government officials started to panic. When Shor's algorithm was released, it hit like a stone thrown into a calm lake, sending ripples of fear and uncertainty across the globe. Can you imagine the scene when Peter first presented Shor's algorithm? He stood at an academic conference and announced, "I've just proven that quantum computing can break your encryption in seconds." The room went silent for a moment. Then, I bet a few colleagues slipped out their phones, checking their bank accounts, wondering, "Wait, does this affect my savings?" You know they were thinking it. This wasn't just some joke. Let's rewind and get to the core of it. In 1994, Peter Shor unveiled his landmark algorithm, Shor's algorithm. He wasn't just a mathematician, he was a pioneer bridging the gap between quantum mechanics and computer science. At the time, quantum computing was still in its infancy. But Shor, with his deep understanding of quantum mechanics, introduced an algorithm that shocked the world. This algorithm turned the once impossible task of factoring large numbers into something much more manageable. And here's the kicker, it's the very problem that underpins the RSA encryption system. In other words, when Shor's algorithm dropped, traditional encryption systems were suddenly at risk of being rendered obsolete. How powerful was this algorithm, really? Shor's algorithm's core concept is the quantum Fourier transform. If you're thinking this sounds like something straight out of a sci-fi novel, don't worry. Shor wasn't dreaming. The quantum Fourier transform is a powerful mathematical tool that speeds up the factoring process. For classic computers, factoring large numbers is a nightmare, it's time-consuming and nearly impossible. But with quantum computers, it becomes a walk in the park. Shor's algorithm took full advantage of quantum bits' unique properties, superposition and entanglement, to drastically accelerate the calculation. Imagine the RSA encryption system, where the size of the numbers makes breaking the code almost impossible. But with Shor's algorithm, it was like hitting the fast-forward button, making that unbreakable encryption system crumble. Sounds like something out of the Matrix, right? But this wasn't fiction, it was real. When Shor's algorithm was released, security experts around the world began scrambling. Governments, financial institutions, even hackers, they all started asking, can we use this to our advantage? The question wasn't just about cracking codes, it was about preparing for the impending quantum era. This wasn't just another mathematical discovery. It opened a door to the future of quantum computing. Before Shor's algorithm, quantum computing was mostly theoretical. But this algorithm was like a key unlocking the door to its practical applications. Suddenly, it became clear, quantum computers were far more powerful than we ever imagined. And Shor's algorithm took quantum computing from a theoretical concept to a tangible, world-changing reality. Fast forward to today, and quantum computing is no longer just an academic subject. It's on the verge of transforming the world. The algorithm that Peter Shor introduced wasn't just a milestone in mathematics, it was a turning point in our understanding of technology itself. Thanks to Peter Shor, quantum computing is no longer a distant dream. And who knows? This is just the beginning. The implications of Shor's algorithm are vast, and it goes beyond encryption. If quantum computers become widespread, they could completely overhaul fields like artificial intelligence, drug development, and materials science. For example, quantum computers could model complex molecules, helping scientists design new drugs at a speed and accuracy that classical computers can't match. So, what does this all mean for the future? Well, we're at the beginning of a new age, one where our understanding of computing will be redefined. And it all started with Peter Shor's bold claim that he could break encryption. With quantum computing, the sky's the limit. And the world is just beginning to catch up. Peter Shor wasn't just a mathematician, he was a harbinger of the future, a visionary who understood that the answers to some of the world's biggest problems could lie in the strange, mysterious world of quantum mechanics. Through his work, he didn't just change encryption, he changed the way we think about computation, security, and the very fabric of reality itself. So, the next time you input your password or make an online purchase, you might just want to think about Peter Shor. Because what he did is about to change the world as we know it. And that, my friends, is no exaggeration. Peter Shor, one of the pioneers of quantum computing, has made contributions that are absolutely beyond measure. His work didn't just stop at the famous Shor's algorithm. He has been a driving force behind the advancement of quantum information science, quantum encryption, and quantum communication. These breakthroughs have revolutionized the way we understand the potential of computers. Imagine for a second, today's supercomputers are no match for the power of quantum computers. They're practically toys compared to what's on the horizon, and it's all thanks to Shor's groundbreaking work. Let's start by diving into Shor's algorithm. Back in 1994, Peter Shor introduced an algorithm that could efficiently solve the problem of factoring large numbers, which is the core of many modern encryption systems. RSA encryption technology, widely used in banks, government, and cybersecurity, relies on the difficulty of factoring large numbers. Traditional computers would take an unimaginable amount of time, sometimes thousands of years, to break these encryption systems. But a quantum computer? It could do the same thing in a matter of seconds. This discovery sent shockwaves across the world. Quantum computers could, in mere seconds, break encryption systems that we consider to be the gold standard of security. This was a major blow to modern security systems, and it left experts wondering what would happen if quantum computers became mainstream. But here's the thing, Shor's algorithm wasn't the end, it was just the beginning of what quantum computing could do. It opened our eyes to the reality that quantum computers have the potential to go far beyond the limits of classical computing. Let's take a closer look at quantum bits, qubits, and how they differ from classical bits. Classical computers work with bits, where each bit can represent either a 0 or a 1. Quantum computers, on the other hand, use quantum bits. A qubit can be in a superposition, meaning it can represent both 0 and 1 at the same time. This means that quantum computers can run multiple calculations in parallel, dramatically increasing computational efficiency. Imagine being able to do several tasks at once, rather than one at a time. Quantum computing's parallelism allows it to surpass classical computers on certain tasks. Now, this might sound like science fiction, but the truth is, quantum computing is no longer a far-off dream, it's already becoming a reality. Quantum computers are not just able to break encryption, they can solve complex problems that traditional computers struggle with. Take chemical molecule simulations, for example. While classical computers might take years to simulate a molecule, a quantum computer could finish it in seconds. This is incredibly important for fields like drug development and material science. Shor's research wasn't just about breaking codes, it opened up a whole new world of technological possibilities. In addition to Shor's algorithm, he's also made major contributions to quantum information science. Quantum computers aren't as stable as classical ones. Qubits are highly sensitive and can easily be disturbed by their surroundings, causing errors in calculations. To address this, Shor introduced the concept of quantum error correction. Because quantum bits have a much higher error rate than classical bits, quantum error correction is crucial to make quantum computers more reliable. Thanks to his work, quantum computers are now on a clearer path toward practical application. One of the most important areas in quantum information science is quantum key distribution, QKD, which ensures secure communication based on the principles of quantum mechanics. In traditional encryption, keys can be intercepted during transmission. But with quantum communication, any attempt to eavesdrop is immediately detectable. Once a quantum state is measured, it changes, so any interference in the system is immediately exposed. This makes quantum communication nearly impossible to hack. The unbreakable nature of quantum encryption is something traditional encryption methods simply can't match. You might wonder, does this mean all existing encryption systems are suddenly obsolete? Actually, the rise of quantum computing has made us much more aware of the importance of data security. As quantum technology develops, quantum encryption is gradually becoming the new standard. This means data exchange will become significantly more secure and less vulnerable to hacking. If you find that your credit card information is no longer safe, it may not be because of a flaw in your bank's system. It could be that Shor's quantum computer is cracking those traditional encryption methods. Quantum encryption is set to become the cornerstone of future cybersecurity. Quantum computing isn't just going to impact encryption technology, it's set to revolutionize other fields as well. Quantum computers can process massive amounts of data in a fraction of the time it would take traditional computers, and solve optimization problems that classical computers can't tackle. For example, quantum computing could help us find the optimal path for a chemical reaction in no time, which has significant implications for drug development. Quantum computing will accelerate scientific research and help us tackle global challenges more quickly. Before long, quantum computing will be pushing technological advancements, leading to a new industrial revolution. Peter Shor's work isn't just a contribution to computer science, it's changed the way we understand technology. The gap between classical computers and quantum computers is like the difference between walking on the ground and flying in the air. Quantum computers can process thousands of pieces of data simultaneously, while classical computers can only handle one at a time. This gives quantum computing an unparalleled advantage. The future we're heading into, with the help of quantum computing, is one where we'll live in a smarter, more efficient world. Although quantum computing is still in its early stages, its potential has already been unlocked by Shor and others in the field. As the technology continues to develop, quantum computing will find its way into various industries. Medicine, climate simulations, financial analysis. Quantum computing is poised to revolutionize them all. And Peter Shor? He's undoubtedly one of the key figures behind this revolution. His work has already begun to change the world we know, and in the future, the widespread adoption of quantum computing, quantum encryption, and quantum communication will make our lives smarter, safer, and more connected. Peter Shor's contributions have paved the way for us to enter the quantum age, and his work is deeply influencing how we live, work, and communicate. From quantum computing to quantum encryption, Peter Shor's contributions are far more than just academic talk. They're starting to impact our daily lives. In fact, the future world may depend on the very technological revolution he's set in motion. Have you ever wondered, in the near future, how secure your accounts will be if quantum computers become mainstream? Well, Peter Shor might just be the reason we don't have to worry. Let's dig into his societal impact. The most direct impact? Internet security and global communication networks. Today, almost all internet security relies on encryption, and RSA encryption has always been at the core of it. RSA encryption depends on the difficulty of factoring large numbers. The bigger the number, the harder it is to break. But the moment Shor's algorithm emerged, that all changed. Once quantum computers become widespread, traditional encryption methods will no longer be secure. Think about it, your bank accounts, social media accounts, and personal data are all built on these traditional encryption methods. If quantum computers manage to crack them in the near future, it would be a nightmare. The biggest advantage of quantum computing is its parallel processing ability. This means that a quantum computer can complete tasks in seconds that would take a traditional computer thousands of years to finish. These computers will solve problems that were once deemed impossible. For example, drug development. Today, developing new drugs requires extensive computing time and simulations. Traditional computers can take years to simulate a molecule, while quantum computers can do it in seconds. This means we can find cures for diseases faster than ever before. Quantum computing isn't just going to revolutionize the medical field, it will also shake up the financial industry. The financial sector relies heavily on data processing and predictions. While traditional computers handle a limited amount of data, quantum computers can quickly analyze much larger datasets. This will make financial market predictions more accurate and investment decisions smarter. Furthermore, quantum computing can optimize supply chain management, risk assessment, and more, bringing more efficient and precise operations to the global economy. Imagine being able to predict market shifts ahead of time. Your investment decisions would be more accurate, and the flow of capital could be smoother. Another major impact of quantum computing is on network security. Have you ever worried about your account being hacked while shopping online or conducting a bank transaction? If you're worried about your password being cracked in the future, quantum computers could be your biggest threat. But here's the twist: it's quantum computing that's driving the creation of quantum encryption technology. The biggest advantage of quantum encryption is that it's nearly impossible to crack. Quantum key distribution, QKD, relies on the fundamental properties of quantum physics to ensure secure communication. Once a quantum bit is measured, its state changes. Any attempt to eavesdrop is immediately detected. This type of encryption will usher in a new era of network security. You won't have to worry about hackers stealing your bank password. If quantum computing can break encryption, quantum communication technology will make our information more secure. QKD, by utilizing the uncertainty of quantum bits, ensures that information transmission is secure and transparent. Any attempt to intercept or alter the message will be immediately detected. Quantum communication will completely change how we think about privacy in the digital age. In the future, all internet communications will be encrypted, and everyone's privacy will be better protected than ever before. Quantum communication will not only enhance the security of information transmission, but it will also shift the way society operates. With the rise of quantum communication, future societies will place a higher value on privacy protection. People will no longer need to worry about their personal information being leaked, and the risks of data breaches will be significantly reduced. Imagine a future where the internet is built on quantum communication, where security and privacy are the top priorities. This is all possible because of Peter Shor's groundbreaking work. He's not just changing the way we understand encryption, he's helping lay the foundation for a more secure and efficient global communication system. As quantum technologies evolve, they'll bring about a new age of smarter medicine, more precise financial decisions, and more secure networks. And at the heart of this revolution is Peter Shor, whose work has already begun transforming the world we know. In the future, quantum computing, quantum encryption, and quantum communication will not just be cutting-edge technologies, they will be foundational parts of our society's infrastructure. Peter Shor has truly opened the doors to the quantum age, and his work will continue to shape our world for years to come. Peter Shor. This name has practically become synonymous with quantum computing. But here's the thing: not everyone knows the full story behind this genius. You see, Peter Shor didn't just have his brilliance to rely on. Behind him stood an incredible support system: his family. Imagine growing up in a house filled with academic conversations, where breakfast discussions weren't about what's for breakfast, but rather, did you hear about the latest quantum mechanics breakthrough? That was Peter's reality, living in a household where his father was a chemist and his mother a mathematician. It wasn't your typical family dynamic, it was more like a crash course in academia. It was in this environment that Peter developed his academic interests, with his parents deeply influencing his approach to learning and discovery. His father, a chemist, encouraged him to look at problems from different angles, while his mother, a mathematician, emphasized logic and abstract thinking. It's safe to say that Peter's academic journey was practically predestined, shaped by a family that didn't just teach him knowledge, but sparked his curiosity about the unknown. Growing up in a home like that, it's no surprise that Peter would eventually change the world of quantum computing. But here's something you might not expect: despite being a giant in the field of quantum computing, Peter Shor is far from being the stereotypical genius loner in a lab coat. In fact, Peter has a gentle and approachable personality, and his relationships with colleagues are known to be warm and cooperative. While many might picture a top-tier scientist as someone who's somewhat distant and focused only on their work, Peter couldn't be further from that. He's a humble, down-to-earth guy who believes that the real progress in science is made through collaboration, not isolation. One of the interesting things about Peter's story is how his personality defies the typical image of a scientist. People might think that geniuses like him are laser-focused only on their research, oblivious to the rest of the world. But Peter Shor, despite his revolutionary work in quantum computing, doesn't bring out a quantum computer at family gatherings to solve math problems. He once joked that would be the worst social activity ever. Instead, he enjoys talking to his family about the little things in life, like his kids' funny school stories. To his family, Peter isn't just a scientist, he's a loving father and husband. His wife has often said that Peter knows how to balance his demanding career with family life, making time to cook dinner or take the kids to the park. He's just as dedicated to his family as he is to his work, showing the world that you can be an exceptional scientist and a caring family member at the same time. His kids admire him, not just for his academic achievements but for the love and attention he gives them. This balance between work and family life has made Peter not only a great scientist but also a wonderful husband and father. Peter's humility extends to his professional life as well. He's known for his collaborative spirit. In the field of quantum computing, especially in its early stages, progress wasn't made in isolation. It required teamwork across disciplines. Peter worked closely with physicists, mathematicians, and computer scientists. Quantum computing sits at the crossroads of these fields, and Peter was always open to learning from others. He wasn't interested in being the leading figure of any project. Instead, he valued the input and ideas of his team, knowing that complex scientific problems are best solved when everyone contributes. His colleagues often describe him as an elegant giant in academia, someone with deep knowledge and skill, but always kind, humble, and willing to listen. What's interesting is that Peter Shor isn't the kind of scientist you'd expect to see up there on a pedestal, isolated from the world. He's not a mad scientist, the kind of person who sacrifices everything for research. On the contrary, he has a sense of humor that often surprises people. When explaining complex quantum theories, Peter has an uncanny ability to weave in clever metaphors, making even the most challenging concepts engaging and fun to understand. His humor feels effortless and natural, which has only helped strengthen his relationships with his colleagues. But even with all the work, Peter never lets his family take a back seat. Despite his groundbreaking research, he has always made sure to keep his home life warm and full of love. His wife has mentioned how Peter finds time to be a dedicated family man, even amidst his busy career. This balance between being a top scientist and a loving, present family member has been key to his success both in the lab and at home. When we look at Peter Shor's journey, it becomes clear that his achievements in quantum computing wouldn't have been possible without the strong foundation of support from his family and the collaborative spirit he fostered with his colleagues. His success in the scientific community wasn't just about his talent, it was about his ability to work with others, learn from them, and balance his professional and personal life. Peter Shor is a respected giant in the world of academia. But at home, he's just a regular guy, someone who loves his family and is committed to spending quality time with them. This balance between his career and personal life may very well be the secret to his success. Whether he's in the lab or at home, Peter Shor embodies the spirit of a humble genius, a person who's deeply respected in his field but who never loses sight of the things that matter most. Now, we live in a world that's defined by classical computing. It's in our smartphones, shopping sites, bank transactions, and social media platforms. Classic computers are the backbone of our daily life, and it's hard to imagine a world without them. But what if the future world is defined by quantum computing instead? Who knows? Maybe we're walking into the quantum age that Peter Shor once predicted. As a pioneer in the field, Peter Shor has undoubtedly changed the way we view the world of computing. His Shor's algorithm didn't just pave the way for quantum computing, it opened up a whole new realm of possibilities in the computing world. Thanks to his work, quantum computing has moved from theoretical concepts to real-world applications. While quantum computing is still in its infancy, its potential is already turning heads globally. The future of quantum computing may come much sooner than we think. With continued research, quantum computers will become increasingly powerful in solving complex computational problems. In the near future, quantum computing won't just revolutionize drug development and scientific research, it will also redefine internet security and have a profound impact on the global economy. Imagine quantum encryption techniques that protect our privacy and quantum communication systems that make information transfer more secure. These once futuristic technologies are not as far off as they may seem. Quantum computing promises to bring us unprecedented computational power. It will unlock technologies and applications we can't even fathom right now. It could change the way we work, live, and even think. From quantum internet to quantum AI, from quantum encryption to quantum drug development, quantum technology will touch virtually every field in the coming decades. While the full application of quantum computing still requires time, its future is filled with boundless possibilities. Every day, more and more scientists and engineers are working to make quantum computing a reality. We might not be able to predict the exact day when quantum computing reaches full maturity, but we know that day will be a monumental milestone in the history of technology. So, if you think quantum computing is still a long way off, just remember this: tomorrow, your world might be shaped by quantum computing. And behind this technological revolution, Peter Shor's contributions cannot be overstated. His work wasn't just about cracking codes, it was a glimpse into the future of computer science. Through his groundbreaking quantum algorithms, he unveiled the mysteries of quantum computers, showing us a new world of smarter, more efficient computing. His efforts have set the stage for the quantum era we're heading toward. The future, it seems, may not belong to classical computers at all. Instead, it could very well be ruled by quantum computers. Imagine a future where banking systems, medical technologies, and artificial intelligence are all driven by the power of quantum computing. Thanks to scientists like Peter Shor, we are on the cusp of a new age, one where quantum computing will dominate and redefine our world. So the next time you enter a password, just remember that might already be cracked by Shor's algorithm. The once distant dream of quantum computing is now stepping closer to our doorstep. And in all likelihood, it's Peter Shor who set us on this path to the quantum age. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.